Hello, this is Aditya, UR16CS008, and this video is for my 7th experiment in data structure lab. What I've done in my 7th experiment is I've made an algorithm or a C+ program for the searching of elements in a data structure. So there are two basic methods of searching. One is the linear search and second is the binary search. What linear search is? Linear search is the basic search algorithm which is used in data structure. Linear search means if you have n number of data, the search for searching any element, you need to get sequentially to one by one elements to check whether to search the data. You need to go one by one element to get that data which we are searching for. Okay, so I made a C++ program for my linear search application. So what I've done in my program is that I've taken two header files of C++ hashtag include iostream and using namespace std. Now I've initialized an integer type array which is of name a, which a maximum size I have already declared to be 20. N is also an integer variable. Then I've made a function, void function, which is named to be linear search, with an argument int item. Okay, then inside this function I've mentioned integer I. I've taken a for loop from where I starts from 0. It will run till I is less than n, and it will increment one by one to reach n. Okay, so if condition I've given, if item is equal to a of I, item means the item or that key which we are searching for in our data structure is equal to a means that array, I is the element, is equal to that item is equal to that element in that array, then we will get successfully searched that item element or the item is successfully searched. If the worst condition is that item does not belong to the array, then we will or the data structure, so we will print out cout not found. Okay, so I made that function. What I've done in my int main is that main function int main int item I. I've taken two integer variables item and I. Now my compiler will ask the user enter the size, means maximum 20 I have inputted already there, but now my compiler will ask the user what is the maximum size of your array, what is the not maximum, what is the size of your array, and that size will be stored in n. Okay, that size will be stored in n. Again my compiler will ask the user to enter what all are the elements which are to be there in the data structure, then which will run under a for loop, because we have to save that element inside an array which is of name a. Okay, so for loop from where I starts from 0, it will continue till I is less than n, and it will increment one by one to reach n. Okay, that will be stored in a of I. I will start from 0 and it will run till n. Okay, that number of elements will be stored in that array. Now my compiler will ask the user that in that data structure which you have mentioned, elements which you have mentioned, which element you need to search, or the key element which you need to search in the data structure. So that input from the user will be stored in item. Item is also an integer variable in which that will be stored. Now that function which I've already made, which is of name a linear search, will be invoked in int main with reference to item, because item is the only integer variable or the argument which we are passing through our function, which is going to search that element. Now I will give you example with the execution of my program. So now my compiler is asking me enter the size. Okay, my size of the array size will be 3. Now it is asking me to enter the elements. My elements is 3, my elements is 4, 5, and it is now my compiler will ask that enter the elements to be searched in this array, which element you need to search. Okay, I am saying that if I need to search 4, okay, then my compiler will say that successfully search in the position 1. 4 is in the position 1. Now again I will show you now again it is asking for size. I've given 3, elements are 6, 5 and 4. Now it is asking me which element you need to search. I have typed 2. 2 is not in the data structure. Now it will show that not found. Thank you. This was for linear search. Now I'm moving on to the second part of my seventh experiment, which is binary search. What basically binary search or the development of binary search is done to decrease the complexity level of the search, because as we have seen in linear search sequentially, the compiler is going to each and every element to search. It is taking a lot of time, and it's not that much efficient. So there is a new method or the new search algorithm which is termed to be binary search. What basically is in binary search is that if you have if you have n number of data structures, so it consider to be it in a straight line. Okay, and there are n number of data structure in a straight line. Now what my compiler will do is break down, and the one of the most important and major thing in binary search is that binary search always accept and sorted array. Sorted element array means it should be sorted either in a descending or a ascending way. It should be sorted. So what in my binary search will do that, my compiler will do that in that sorted elements, it will first break down into two halves. Means if there are total n elements, it will break down into n by 2. If it is broken in n by 2, now the element which I need to search, my compiler sees that whether it belongs to the left half or the right half. Okay, if it belongs to the left half, then right half will be removed from that searching list, and it belongs to right, left will be removed. Again the same is been going on through that again that left half will be broken down into two halves and one will be removed. This is the main implement which has been taken in a binary search. So again by using the header files, now we'll see what I've done in binary search, what I've done in that function named binary search. So in binary search, middle and left is first initialized to 0 and right is initialized to n minus 1. N is the total elements and it is stored to be n minus 1. Okay, while when left is left is less than equal to right, mid is equal to left plus right by 2. Means if left is less than equal to right, mid is equal to n by 2, means total number of elements divided by 2. If a of mid equal to element, a of means element which we need to search is present in the array name of a in the middle, then return mid plus 1. If else, if the element which we need to search is greater than the mid, then the right will change, the right position of that data means searching list will change, and else if it is not, then the left part of the data left limit of the searching data structure will change. Okay, what I've done in my int main is that initialize array name a of maximum size 20. Item I've taken I temporary variable I've mentioned to be 0. Now my compiler will ask enter the size of that maximum or the size of the elements which are there in the array that will be stored in n. Elements will be stored in our loop one by one. Okay, now what we have done over here is just to make the element in a sorted form, just for a sorted form array elements which we have used these functions. Okay, now what is the main function is that it will search and search. Now my compiler will ask enter the element which you need to be searched, and that will be stored in item. Then my function of binary search will be invoked and it will carry on. Now I will show you with the help of an example. Okay, my compiler will ask enter the size might be 4. Enter the elements will be 10, 12, 14 and 16. Now enter the this is the sorted form which my compiler has done. I've already mentioned the sorted form, but again my compiler makes it in the sorted form. Enter the elements to be searched. I need to search 12, so 12 is at the second position. So thank you. This was my 8th experiment in data structure lab.